Today we're going to be starting section 5.1, dealing with measures of angles and rotations. For the most part, chapter 5 is going to be reviewed. Chapter 5 is going to deal with degrees and radians, leading into trigonometry for the second half of the chapter. So before we can get on to the trigonometry, we're going to look at measures of angles and rotations, objective, pretty much just one for this first section. You're going to convert between degrees, radians, and revolutions. So we're going to start with, and hopefully give you some time to go through this quickly, but I want to go through and just make sure that we're set as far as a couple of terms. First off, definition of an angle. Angle is a union of two rays with the same endpoint. The union of two rays with the same endpoint. The point that is the endpoint for the two rays is referred to as the vertex. And we can look here. The vertex of the angle is going to be where the two rays extend from, and then the two sides are going to just be called sides, obviously. Okay, so angle is a union of two rays with the same endpoint. Then, moving on, measure of an angle is a number that represents size and direction of rotation used to generate the angle. Biggest thing that I would say on this is that not only do you have to identify the measurement, but you also need to give direction. And the direction of the angle is going to be implied either by a positive or a negative. And we'll talk about which is which here in a few seconds. But there are two things when we're looking at an angle. One is going to be the measurement. Could be in degrees, could be in radians, could also be referred to as what is called revolutions. And then secondly, plus or minus will determine which direction the angle is opening or rotating. So, the direction, a clockwise turn is negative, a counterclockwise is going to be positive. And we're going to focus right now on degrees. So we're going to look at this in terms of degrees, then talk about radians, then talk about revolutions. So clockwise is negative, counterclockwise positive. Easiest way to remember that, think about time. As a clock is moving forward, you are losing time, which is a negative thing. Okay? You're losing time, and time's running out. Counterclockwise, think about this fall when we turn the clock back an hour. So turning it backwards would be counterclockwise. That's a positive thing. And a couple weeks ago when we had turn back the clock night on a Saturday night, you gained an extra hour of sleep, and I am sure most of you at that point in time viewed that as a positive thing. Okay? So, here, if I have angle ABC, vertex is at B, I have sides BA and BC, and I have 60 degrees. Depending upon which side I look as the initial side. Now to start with, if I look at side BA as my initial side, then I am rotating clockwise 60 degrees. Okay? Since it is clockwise, that is why the angle measure would have a negative attached to it. Because it is turning clockwise from BA to BC. Now that being said, if I look at BC as my initial side, then to get to BA I am rotating it counterclockwise, in which case the angle would be positive 60 degrees. So it's still the same measurement, 60 degrees either way. The positive or negative is just determined by if I know there is a rotation. Now, if I just draw you an angle and you measure the angle and you don't know which the initial side is and what is called the terminal side is, then you could just put 60 degrees or 45 degrees or whatever the case may be and be done with it. Okay? Revolution. Okay? Now, when we talk about revolution here, we're talking about turns. We're not talking about, an uprising. Revolution is another unit for measuring angles. 1 revolution clockwise is negative 360 degrees. Just remember clockwise is negative. So a revolution simply is once around the circle. So 1 revolution is equivalent to 360 degrees. Half a revolution would be 180 degrees. Now notice I've thrown in a couple counterclockwise and clockwise just to kind of show off the positive and negative. 45 degrees would be 1/8 of a revolution. Now, obviously, not going over how you get it, but if 1 revolution is 360 degrees, if I have 45 degrees, you simply divide by 360, and that's going to give me 1/8 of a revolution. Okay? So, here's our formulas. If I have revolutions, to get it to degrees, simply multiply by 360. If I have 2 revolutions, that's 2 times around the circle. 2 times 360 would be 720 degrees. So to get your degrees, you're going to take your revolutions times 360. Going the other way then, if I have degrees, divide by revolutions, and divide by 360, that's going to tell me how many revolutions. So if I have 400 degrees, 400 divided by 360 over here, clear everything out, maybe. And it looks like our calculator has defeated us. So we'll see if we can pull it back up here. Okay. And see if this guy works for us. There. Okay. But I would go 400 degrees divided by 360. Answer is 1.1 repeating. And if I hit math, convert to fraction, I could say it's 10/9 of a revolution, or 1 1/9 of a revolution. Okay, so degrees and revolutions. Next item, okay, is a base 60 system, which is called a sexagesimal system. Now, base 60 system deals with angles. If I take an angle and I break it down, angles are broken up by degrees, and then each degree consists of 60 minutes. So for every 1 degree, there are 60 minutes. Think in terms of a degree is similar to an hour, where an hour has 60 minutes, and then 1 minute is 60 seconds. And so when we break down our degrees, I could have 45 degrees, 22 minutes, 32 seconds. And that would be part 45 degrees plus an additional part. So, if I have 40 degrees, 37 minutes, and 16 seconds, I would have 40 plus 37 divided by 60, 37 minutes divided by 60 minutes gives me degrees, plus 16 over 3,600. Now the 3,600 is because I have 60 minutes times 60 seconds. So 60 times 60 is 3,600. Okay? So if I do that, I would come over here and type 40 plus 37 divided by 60 plus 16 divided by 60 squared, or 3,600, and the answer is 40.621 degrees, okay? And that would give us the decimal equivalent. Okay? Now, nice thing here is, to do degrees, minutes, and seconds, the degree button can be found by going to above the word apps, you'll see angle. Okay? You hit the second and then the apps button, and then you'll get angle. and you'll see degree is there and minutes is there. And then the seconds, unfortunately, and this is going to be tough to do on a video, but the seconds is located by hitting alpha and then the plus sign. And if you look over there, you'll see in green the seconds. So if I want to type in, say 40 degrees, 37 minutes, I'm going to go 40 degrees, hit the second angle degrees, and now I have a degree symbol. 37 second angle, or second apps, which gives to the angle, minutes. And if for whatever reason they didn't put the seconds here, I think it's the dumbest thing ever. They put degrees and minutes in one location, and then second, to get to seconds, I'm going to type in 16, and then I have to hit alpha plus sign to get my seconds. And so if I type that in and hit enter, it goes to 40.6211, which is a lot faster than having to actually physically do all of this addition here. Okay, so for what it's worth. Now the other nice thing that you could do here is, let's say I give you 58.7235 degrees, and I want to convert it to degrees, minutes, and seconds. DMS, degrees, minutes, seconds. What I can do is take my calculator, type in 58.7235, and then if I go back to where my angle is, underneath degree, underneath minute, choice number 4 says arrow DMS. And what this will do is it'll take any decimal and convert it to degrees, minutes, and seconds. So if I take 58.7235, arrow DMS, I have 58 degrees, 43 minutes, and 24.6 seconds. Okay? Kind of nice. Whew. You guys good so far? Okay. Well, moving on, we still need to talk about radians. And then we're starting to get close to be done. So, radian defines an angle based upon circumference of the unit circle. Unit circle is a circle centered at the origin, radius 1. Okay. If I have a circle whose radius is 1, the circumference of the circle is 2 pi r, but if my radius is 1, it's just 2 pi, and again, that's my circumference. And so 2 pi represents the distance around the circle. Okay? So if I look at any circle, at any point, if I were to travel around the circle, the distance that I would travel is 2 pi, if the circle is a radius 1. Okay? So, here's our rule. 360 degrees is 2 pi radians. Okay? Once around the circle is 360 degrees. Once around the circle is 2 pi radians. Therefore, 90 degrees would be pi over 2. 180 degrees would be pi. Radians. Okay? So, a whole circle is 2 pi, which is 360 degrees. Half a circle would be half of 2 pi, or pi. 90 degrees is 1/4 of a circle. 1/4 of 2 pi is pi over 2. So conversions here. If I have degrees and I want to convert to radians, I multiply by pi over 180. Now when we are doing these conversions, please listen carefully. Leave pi as pi. Do whatever multiplications or divisions you need to do, but leave pi as pi, unless you're told to, round to the nearest hundredth. Okay, so we're going to leave pi alone. Don't touch the pi, leave the pi alone. So to get radians, I'll take whatever the degree measure is and multiply by pi over 180. Going the other way, if I have radians and I want to get degrees, I multiply by 180 over pi. Okay, for some reason, some of these fraction bars aren't coming in. Okay. The general rule that I would give you is whatever you are converting to goes in the numerator. If you can just remember 180 goes with pi. And then whatever you want on top, or whatever you want to have, put on top. Now, if I were here, I'd say something stupid like, think about, for some of you, you celebrate birthdays or Christmas, holidays and such. What I would say is this. When it comes time for Christmas, when I was growing up, I would create a list that my parents would deliver to Santa. And whatever I wanted the most, I would put on the top of the list. And then the other things would kind of go down. So the socks and underwear and stuff like that wouldn't go towards the top, but the G.I. Joe with the Kung Fu grip up at the top of the list. So, same rule applies here. If I want radians, okay, then I'm going to put the pi on top, 180 on the bottom. If I want degrees, then I put the degrees on top. So for radians, pi goes on top, 180 on the bottom. To convert to degrees, 180 goes on top, pi goes on the bottom. So, hope that helps. But again, all this should be review. So, here are some practice converting each to the requested unit. So, we'll give you about 2 minutes. See if you can do those conversions. Okay, and then we'll come back. Now, as you are working through here, one advice that I would give you, if you notice, I did the conversions from degrees and revolutions and back and forth, and then I did degrees and radians. Really didn't give you radians to revolutions. And the whole reason I didn't do that is so that you didn't have more stuff that you had to memorize. So my advice is, if I give you revolutions and I want you to turn it to radians, take the revolutions, convert it to degrees, then take the degrees and convert it to radians. No, it's a little more work, but it's not as much memorizing as far as formulas. Okay? So we'll give you about another minute to see if you can get done with this. And the 6 examples, notice the first 2 are degrees to the other 2. The next 2 are converting revolutions to degrees and radians. And then the last 2 are converting radians to degrees as well as revolutions. So again, my advice, anytime you're doing radians to revolutions, or vice versa, or radians or revolutions to radians, my advice is I would kind of use degrees as your intermediate. Okay, so with that in mind, I'm going to go ahead and at least start setting up. The first one's 55 degrees to revolutions. Since one revolution is 360 degrees, we would just take 55 divided by 360. Now if you want, you could just put 55 over 360 revolutions. Or we could go to our calculator, 55 divided by 360. Answer is 0.1527. I would go math converted to fraction and get 11/70 seconds. So 55 degrees is 11/70 seconds of a revolution. I like the fraction versus you trying to round decimals. Negative 160 degrees to radians. I write 160 degrees. Because I want radians, I'm going to put pi on top, 180 on the bottom. Now, as I said before, we're going to leave pi as pi. So over here, I'm going to go negative 160 divided by 180, hit enter, decimal, hit the math button, convert it to fraction, and I get negative 8/9. So my answer would be negative 8 pi over 9. Okay, the pi stays in the numerator. Next one, 1.25 revolutions to degrees. I know that there are 360 degrees for every revolution, so I would take 1.25 times 360 degrees. 1.25 times 360. Answer is 450 degrees. Now, a way to look at it, one revolution would be 360 degrees. Quarter of a revolution would be 90 degrees. 360 plus 90 is 450. Now, this is the one I'm talking about, going revolutions to radians. What I would do is I would take my revolutions times 360 to get my degrees. Now, 3/4 of 360 degrees is 270 degrees. So 0.75 revolutions is 270 degrees. Then to convert to radians, put pi on top. So multiply by pi over 180. And if I do that, I just take 270 divided by 180. Answer is 1.5. Convert to fraction. I end up with 3 pi over 2. You might as well get used to it. Usually when you give radians, you'll give it as a fraction with pi. Okay, in this case, an improper fraction. So, 3/4 to degrees. I'm going to write 3 pi over 4 times, now because I want degrees, I put 180 over pi. The pi's cancel out, and I have 3/4 times 180, which I believe is 135 degrees. Okay. And then the last one, negative 5 pi over 6, and I want to convert it to revolutions. So first thing I'm going to do is take negative 5 pi over 6, multiply it by 180 over pi to get it into degrees. If I do that, my pi's cancel out. Negative 5/6 times 180, negative 150 degrees. But then I still need to get it over to revolutions. So divide by 360 because there's 360 degrees in a revolution. So I go divided by 360 and the answer is 0.4167. And lo and behold, I'm going to go math convert to fraction again and I get negative 5/12 of a revolution. Okay? So again, I'm trying to keep this somewhat short so you can get started on the assignment. Moving to the next page. There is no next page. Okay, so I guess I better come down here and see if homework assignment. There it is. So our homework assignment, pages 272 to 273, problems 1 through 27. Now, I will post this video on, upload it to YouTube, and then I will attach the link onto the Moodle webpage. So if you do want to go to FST, go to my class on the Moodle webpage. You should be able to go there and be able to get done what we need to get done. Okay?